Hello everyone. In this example here, we are discussing an RC circuit scenario. Now I have a 10 kilo ohm resistor and a capacitor are connected in series with a 12 volt battery. The potential difference across the capacitor rises to 9 volt in 2 microseconds. So I have a scenario here from the discussion or from the description we have in the question. It's showing it's a charging process because I do have a battery with a resistor and a capacitor are all connected in series. I have a 12 volt battery with a 10 kilo ohm resistor and unknown capacitor from the described scenario. Now what the question asking me to find or to calculate is to calculate the time constant and to find the capacitance of the capacitor. Alright, now as a start we said it's a charging process. That's one, so that will help us to visualize or process the scenario of the question. The second thing is mentioning or talking about the potential difference across the capacitor. So I have enough information about the voltage across the capacitor after 2 microseconds, and I know what's the maximum voltage this capacitor could reach, which is the same voltage of the battery. From here I can say, alright, the voltage as a function of time across the capacitor will be the voltage of the battery multiplied by 1 minus exponential t over tau. Okay, now what information I have, it's the voltage of the capacitor when time is 2 microseconds, and I will have here the voltage of the battery 1 minus exponential t over tau. Cool. Alright, now the voltage across the capacitor when the time is 2 microseconds is 9 volt. The maximum we can reach, which is the battery, it's a 12. 1 minus exponential minus 2 micro over tau. Okay, tau is the time constant we're trying to find in this scenario. So to solve this, 9 over 12 equal 1 minus exponential t over tau, or we can say instead of the t here, I can write it is 2 micro. All right, now we're just rearranging the formula again. Exponential minus 2 microseconds over tau equal 1 minus 9 over 12. That will be it's 0.75, which is here 0.25, and that's the exponential of 2 micro over tau. Alright, I can continue here. Okay, to solve this equation we apply the ln, and if I take the ln for both sides, that will end with minus 2 micro over tau equal ln 0.025. Now just to rearrange the formula, it's minus 2 10 to the minus 6 over the ln of 0.025. Sorry, let's erase this quickly. That's gonna be ln 0.25, and that will take us with simple calculation to the value of 1.43 microseconds. So that is the time constant of this circuit. Alright, now to find the capacitance of the capacitor, that should be a very quick and easy one to do. Now we know, we can go to the next page, we can say, alright, tau equal R times C, so C will equal time constant divided on the resistance. That will 1.43 10 to the power minus 6, and the resistor was 10 kilo times 4. and that will give us 143 uh, picofarad. That will be the capacitance of the capacitor we used in this circuit. So in this example, we have a scenario telling us it's a charging process. The time constant was missing in this formula, so we used the information given about the potential difference across the capacitor at specific time. So we managed to identify which formula we should use from the charging process, which is related to the voltage across the capacitor. We did the steps and we convert the equation to a linear equation. From there, we found what is the tau, or the time constant. Next, we managed to find the missing capacitance of the capacitor from finding the time constant, and it should be, that's the process. I hope you found this example useful, and I hope to see you again. Thank you.